Hello, I am Sunita. Welcome to my class. Here I am going to discuss Karnataka TET science topics according to the syllabus. Here the topic is light. In that one, reflection. This is my second class. Those who not saw first class, see that one. Then you can follow the part 2 reflection very easily. Spherical mirrors. A spherical mirror is a mirror that has the shape of a piece cut out of a spherical surface. Here, this is a spherical mirror. This is nothing but a part of a sphere, a section of a sphere of radius r, and also center of curvature C. Spherical mirror is nothing but this is the sphere. In the sphere, if you consider a part or section of a sphere, that one we will call it as a spherical mirror. There are two types of spherical mirror. One is concave, another one is convex mirror. This is the type of a concave mirror. Here you can observe this is also a part of a sphere, but here the outer surface we will call it as a reflective surface. It will act as a reflective surface. The outer surface of the sphere, here it will act as a reflective surface. This type of mirror we will call it as a concave mirror. Then in the case of a convex mirror, this is also a part of a sphere, but here the inner part of the sphere, it will act as a reflective surface. This is the reflective surface. This type of mirror, we will call it as a convex mirror. Terminologies. There are few basic terminologies that one need to know while studying spherical mirrors, and they are center of curvature, the point in the center of the mirror that passes through the curve of the mirror and has the same tangent and curvature at that point. Center of curvature, this is same as center of the circle. This is the center point of the mirror that passes through the curve of the mirror and has the same tangent and curvature at that point. Center of curvature is nothing but center part of the spherical mirror. The next one, radius of curvature. It is the linear distance between the pole and center of curvature. Radius of curvature is nothing but radius of the circle. It is the distance between the center of curvature and the pole. Principal axis, the imaginary line passing through the optic center or center of curvature of any lens or a spherical mirror. This is the principal axis. Principal axis is nothing but the imaginary line that passes through the center of curvature and the pole. Next one, what is meant by pole? The midpoint of spherical mirror. Here this is the spherical mirror. The midpoint of the spherical mirror, we will call it as a pole. An aperture of a mirror or a lens is a point from which the reflection of light actually happens. It also gives the size of the mirror. This part, it will show the aperture. It is the part where the reflection of light it will takes place. Then it will decide the size of the mirror. The next one is principal focus. Principal focus can also be called focal point. This is the principal focus or focus point. It is on the axis of a mirror or a lens where the ray of light parallel to the axis converge or appear to converge after the reflection or refraction. Principal focus, this is the point where the parallel beam of light, they will fall on the curvature or sphere or the reflecting surface. After reflecting or refracting, they will converge. Converge means they will meet at a single point. That point we will call it as a principal focus. In some lenses it will converge. In some lenses the rays it will get diverge. After diverging, if you extend the lines, then it will meet at a single point. Again it will converge. At that point we will call it as a principal focus. Here in the principal focus, the parallel beam of rays, they will fall on the curvature. They will meet at a single point. That point we will call it as a principal focus. The next one, focal length. The distance from the pole to the focal point is called as a focal length. Focal length is nothing but the distance between pole of the mirror to the principal focus or focus. Types of spherical mirror. Here you can see two types of spherical mirror. One is concave mirror, another one is convex mirror. Let us discuss in detail. Concave mirror. If a hollow sphere is cut into parts, the outer surface of the cut part is painted, then it becomes a mirror with its inner surface as the reflecting surface. This type of mirror is known as a concave mirror. Concave mirror, how you will obtain a concave mirror? Hollow sphere, consider a hollow sphere cut into equal parts, then outer part of the hollow sphere is painted, then it will act as a mirror, then the inner part it will act as a reflecting surface. This type of mirror we will call it as a concave mirror. In the case of a concave mirror, you have to remember the inner surface of the sphere it will act as a reflecting surface. The outer sphere is coated with a painting. Then next one, characteristic of a concave mirror. Light converges at a point when it strikes and reflects back from the reflecting surface of the concave mirror. Hence it is also known as a converging mirror. You know, when parallel beam of light, when it falls on the concave mirror, then after hitting the concave mirror, they will meet at a single point. That point we will call it as a converging point, or that process we will call it as a converges. After reflecting the parallel beam of light, after reflecting the concave mirror, they will meet at a single point. That point you are getting an image. This process we will call it as a converging. This type of mirror we will also call it as a converging mirror. Then when the concave mirror is placed very close to the object, a magnified and virtual image is obtained. When you keep an object near to the concave mirror, then you will get a magnified and virtual images obtained. The next one, however, if we increase the distance between the object and the mirror, when you increase the distance between the object and the mirror, then size of the image is reduced and the real image is formed. Then size of the image is reduced and you will get a real image. The image formed by a concave mirror can be smaller or larger, can be real or virtual. Here, which type of image you will get in a concave mirror means the image will be small or large, can be a real or virtual. Convex mirror. If the cut part of a hollow sphere is painted from the inside, then its outer surface becomes the reflecting surface. This kind of mirror is known as a convex mirror. Here, convex mirror is the part of the sphere. The inner part of the sphere is painted. It will work as a hard surface. Then the outer surface of the sphere, it will act as a reflecting surface. This type of mirror, we will call it as a convex mirror. Next, characteristic of convex mirror. A convex mirror is also known as a diverging mirror, as this mirror diverges light when they strike on its reflecting surface. When parallel beam of light, when they will fall on a reflecting surface, then after reflecting they will get diverged. They will not meet at a single point. If you extend the diverging lines, then they will meet at a single point. Then you are getting an image. Then here, which type of image you will get here? The image may be virtual, erect or diminished image are always formed with a convex mirror, irrespective of the distance between the object and the mirror. In the case of a convex mirror, you will get a virtual, erect or diminished image. Then here, irrespective of the distance between the object and the mirror, the image formed, it will not depends upon the object and the mirror position. This is the type of a convex mirror. Concave mirror ray diagram. What is the use of ray diagram? Ray diagram, it will indicate the position of an object and even position of the image also, and nature of the image. All the information it will be given by ray diagram. Therefore, ray diagram is very useful when you are discussing, otherwise when you are studying the image formation, maybe concave or convex mirror. Even in the case of lens also, it will be very useful. Here consider first case, concave mirror ray diagram. Let us understand that when an object is placed at the infinity, when you place the object as infinity, a real image is formed at the focus. The size of the image is much smaller compared to that of an object. Let us discuss in detail. Here you are keeping the object at the infinity. Then here when you are drawing a ray diagram, normally two rays we will consider whether they will intersect, whether they will diverge. Therefore, normally the two rays we will consider. Here also we consider two rays. The two rays must be parallel to the principal axis. This is the principal axis. The principal axis is nothing but the imaginary line passing through the center of curvature and the pole. This is the principal axis. Then consider two rays that they will be parallel to the principal axis. After hitting the concave mirror, then they will get reflected and they will meet at a single point. That point we will call it as a focus. At this point the image it will form. Whenever the two rays they will meet at a point, at that point the image it will be formed. In this case, when you keep the object at infinity, then the image it will form at the focus. And compare the size of the image. The size of the image is decreased compared to the size of an object, and the image it will be real because you are getting the image on the screen. Therefore the image it will be real. Here one thing you have to remember, in the case of a concave mirror, when you place an object at infinity, then you are getting an image at the focus, principal focus. The image may be real, then the size of the image is much smaller compared to that of an object. Let us consider second case. When an object is placed behind the center of curvature, this is the center of curvature. When you keep an object behind the center of curvature, the real image is formed between the center of curvature and focus. In between these center of curvature and focus, the real image is formed. Then size of the image is smaller compared to the size of an object. Let us discuss in detail here. Here, this is the position of an object. You are keeping the object behind the center of curvature. Here also we are considering two rays. One is this one, another one is this one. Already you know, if any ray is parallel to this principal axis, this is the principal axis, this is the ray parallel to the principal axis. If the ray parallel to the principal axis, after reflecting, always it will passes through the principal focus. Always it will passes through the principal focus. Once again I will explain. If any ray is parallel to the principal axis, after reflecting, after hitting the reflecting surface, after reflecting, it will passes through the principal focus. That is the law you have to remember. That is the first one. Then second one, if any rays, if it is passes through the center of curvature, here this the ray, it will passes through the center of curvature. Then after hitting the reflecting surface, it will reflect in the same path. It will reflect in the same path. This is also the second standard law. That one also you have to remember. Once again, listen here. If any ray, if it is passes through the center of curvature, after hitting a surface, reflecting surface, in the same path, it will get reflected back. Therefore, these two rays, this is the parallel rays. After hitting this one, it passes through the principal focus. Then next one, another ray, if it is passed through center of curvature, again it will reflect it back in the same path. Both rays they will meet at this point. Then this is the position of an image. Position of an object we will represent it by A, B. Then position of the image will be A dash, B dash. Then here you are getting a image is real because you are able to get the image on the screen. Therefore, it is a real. The next one, compare the size of the image here. Size of the image is smaller compared to the size of an object. These 2 points are very important. You have to remember. Okay. The next one, if you keep an object behind the center of curvature, then the image you will get between the center of curvature to principal focus. Then the whatever may be the image you are getting, that is real, and the size of the image is smaller compared to the size of an object. Next one, when an object is placed at the center of curvature, if you place exactly at the center of curvature and focus, the real image is formed at the center of curvature. The real image, it will form exactly at the center of curvature, and the size of the image is same as compared to the size of an object. Let us discuss in detail here. AB is the position of an object. Here also we are considering two rays. First ray, this is the ray AD, this ray is parallel to this principal axis. Already you know, if any ray is parallel to the principal axis, always it will passes through the principal focus. This is the ray AD is parallel to the principal axis. Then after reflecting the surface, after hitting the surface, it will get reflected. Then it will passes through the principal focus F in this way. Then it will meet at A dash. It will reach at A dash. Then next one, consider second ray, that is AE. If any ray is passes through the principal focus, after hitting the reflecting surface, it will reflect in the it will reflect in the direction in a way like that it will be parallel to the principal axis. This is the direction of the reflected ray. It will indicated by A dash, A dash. Once again, this is the second interesting law here. If any ray, if it is passes through the principal focus, then after hitting a reflecting surface, it will reflected back parallel to the principal axis, parallel to the principal axis. Therefore, this ray ADF, it will meet at A dash. Then AFE, this also it will meet at A dash. Both the rays, they will meet at A dash. Then after extending this one, you will get A dash, B dash is the position of an image. Then here the image, whatever you will get is a real, the image you will get on the screen. Then the size of the image, look at here, the size of the image is same as the size of an object. Then here the image exactly it will form at the center of curvature. That is very important. That point also you have to remember. In this case also we are considering two rays. One ray is parallel to the principal axis. It will pass through F. Then another ray is passes through F. After hitting, it will emerge, otherwise it will converge. Like that, it should be parallel to the principal axis. Both they will meet. Then this is the image position at A dash, B dash. Then here you will get an object. Size of an object, size of the image, both also it will be same, and the image will be real. Then you are getting the image exactly at the center of curvature. Next one, when an object is placed in between the center of curvature and focus, when you keep an object between the center of curvature and focus, this is the position of an object AB. Then you will get a real image is formed behind the center of curvature. Behind the center of curvature, you are getting an image A dash, B dash. The size of the image, the size of the image is larger compared to the size of an object. Let us discuss in detail here. AB is the position of an object here. Then here also we will consider two rays. First ray is AD. This ray is parallel to this principal axis. Therefore, if any rays, if it is parallel to principal axis, after hitting a reflecting surface, it will passes through the principal focus. Therefore, AD, after hitting the surface, it will passes through principal focus in this direction. Then it will meet at a single point A dash. The next ray, if any ray is passes through the center of curvature here, then if it is passed through the center of curvature, after hitting the reflecting surface, it will come back in the same direction. It will meet at a single point A dash. Here also we will consider two rays. Two rays also they will meet at a single point A dash. Therefore, this is the position of image. The image it will form at this position. If you extend this one, then you will get the position of an image. Here also we will consider two lines. Listen here. This is the AD. This ray is parallel to the principal axis. then it will passes through the principal focus, then it will reach the point A dash. Another way, it is passing through the center of curvature, then after passes through the center of curvature, after hitting this reflecting surface, it will reflect back in the same path, then it will reach at the point A dash. Both the rays, they will meet at a point A dash, therefore the image it will form in this direction. Then here you are keeping the object in between the center of curvature to focus, then you are getting the image beyond the center of curvature. Then here you will get an image exactly on the screen, therefore the image is real. Let us compare the size of an image. The size of an image is larger compared to the size of an object. These all the points you have to remember. Next one, when an object is placed at the focus, the real image is formed at the infinity. The size of the image is much larger compared to the size of an object. A, B, this is the position of an object. If you keep the object exactly at the focus point, here also we will consider two rays. First ray is passes through the center of curvature. You know, if any ray is passes through the center of curvature, after the hitting the reflecting surface, it will passes, otherwise it will bounce back in the same path. Therefore, it will passes through the center of curvature. In the same path, it will get reflected. The next one, second ray, if any ray is parallel to the principal axis, after hitting the reflecting surface, then it will passes through the principal focus F. Then here you can observe these two rays, they will not meet at a single point. Here you can't observe on the screen, but after extending at the infinity, they will meet at a single point. Here at infinity, we don't know exactly at what point they will meet. At that point, the image it will form. Therefore, here the image we will get, here the image is real because the image you are getting on the screen. Therefore, the image is real, and where you are getting the image, you will get the image at infinity. Then the size of the image is much larger compared to the size of an object. Next one, when an object is placed between the focus and the pole. This is the position of an object in between the focus and the pole. Then you will get a virtual and erect image is formed. The size of the image is larger compared to the size of an object. Let us discuss in detail. Here this AB is the position of an object. Then consider here also consider two rays. One ray is parallel to is passing center of curvature. After hitting the surface, again it passes through the same path. This is the one. Then another ray, it passes through the pole. It will hit exactly at the pole, then it will get reflected in this direction. Here this is the diverging case. These two rays, they will not meet at a single point in front of the mirror, but after extending these two rays, then they will meet at a single point A dash. A dash, B dash is the position of an image. Here you are getting an image beyond the screen, therefore the image is virtual and also erect. Virtual image is nothing but when you are getting an image beyond the screen, that type of image we will call it as a virtual and erect image. Here the position of an object is in between focus and pole. Then here you will get an image beyond the mirror at the position A dash, B dash. This is the nature of an image. Then the size of an image is more compared to the size of an object. The nature of the image is virtual and erect because you are getting an image beyond the mirror. Let us summarize here. Position of an object. If the object is at infinity in the case of concave mirror, position of image you will get at the focus F. Size of the image is highly diminished. Nature of the image is real and inverted. Second one, position of object is beyond the center of curvature C. Position of the image is between F and C. Size of the image is diminished. nature of the image is real and inverted. Third one, position of an object is at the center of the curvature C. Position of image at C, same center of curvature. Size of the image, same size as that of the size of an object. Then nature of the image is real and inverted. Fourth one, position of an object is between C and F. Position of image is beyond C. Size of the image is enlarged. Nature of the image is real and inverted. Fifth one, position of object as focus F. Position of image at infinity. Size of the image is highly enlarged. Nature of image is real and inverted. Here one thing you have to remember, what is mean by real. Real is nothing but the image you will get on the screen, that is real. Inverted means the object position, it will become ulta, it is inverted. Then virtual means the image you will get beyond the mirror, that one we will call it as a virtual image. Thanks for listening my class. Send me your valuable feedback. Follow all my classes regularly, then you can clear your TET exams very easily. Which are the topics I am discussed here? The topics are very important. Therefore, follow all my classes. It will be very easy for you to clear TET exam.